Welcome back to our Crash Test Center report. We're continuing our tour of the Audi testing facility in Ingolstadt. We have a few more things to see before the grand finale, the frontal crash. Here's what we'll be looking at. Roof strength test, belt tension test, free motion head test, pedestrian protection, and test sledge and frontal crash test. We're now back in the Audi testing facility. What you see behind me is the test bed for roof strength tests. It's used to simulate a rollover. Albert Karges knows exactly how these tests are performed. Hello, Mr. Karges.
Hello, Ms. Koenig.
So what happens here?
We work to develop stronger roofs for our vehicles. That includes testing according to the legal requirements, which our internal Audi requirements meet and exceed.
So how is this test carried out in practice?
The vehicle is submitted to a force equal to several times its own weight. The interior must stay rigid. Special protective measures have been taken to ensure a safe area for passengers. Our job is to ensure that the roof is strong enough.
So when the weight is lowered, it pushes the roof in, and it can only go to a certain level.
That's right. This is an intrusion into the driver's interior space, into the passenger compartment. It is moved with a force of several tons.
I see that the warning light is on. That means it must be time to start. Shall we watch the first test?
Sure.
3, 2, 1, start!
The test results show that the vehicle does well on rollover safety.
We met legal and internal requirements and are satisfied with that.
Then everything went well. Thanks for the demonstration.
You're welcome.
The carriage is important to ensure safety in a rollover, but so is the safety belt. Safety belts must be tested and meet safety standards too. We're now going to go and see where they're tested. Safety belts are both vitally important and indispensable. They can save lives in major crashes, and they too are tested on a test bed. And Mr. Hackner is the man in charge of it. Hello, Mr. Hackner.
Hello.
What exactly do you test here?
We test the stability of the seat belt anchoring.
We've prepared some footage to show how such a test is done. Can you tell us a bit about the testing procedure?
Okay. The test parts, the chest and stomach, are positioned as required. They are then pulled with chains on a cylinder mechanism. The chains are checked. This is to ensure that the angles meet the requirements. We've done this. Then force is applied. It's 13.5 kilonewtons, which is held for 10 seconds. Then we have the Audi tensile load requirements of 16.2 kilonewtons, which is also held for 10 seconds.
So Audi requires more than the legal requirement.
Exactly.
So now we've tested the safety belt and have seen a carriage on a test bed for a roof strength test. Both are extremely important in protecting passengers. What other ways are there to enhance passenger protection?
There are other tests, like the free motion head test next door.
Thank you, Mr. Hackner. Then let's head over. We'll continue with the interior of the vehicle and go to the next test bed to view a free motion head test. This component test simulates the head impacting different parts of the interior paneling. In some accidents, a passenger's head may strike various parts of the interior. This is why paneling components are designed to deform upon impact and are supplemented with special cushioning. This lessens the likelihood of injury. Using the free motion head test, the interior is tested to see if the safety precautions meet legal specifications and our more stringent internal specs. So, Mr. Neff, we've seen a few examples of tests designed to protect passengers in an emergency.
That's right, but we don't forget others who could be involved in an accident, for example, pedestrians.
It's tough for them. They don't have a crumple zone surrounding them or airbags that they can pop on. How can we protect pedestrians?
I'll use the car to demonstrate. If a pedestrian hits his or her head on the bonnet, it is important that the bonnet has some give to it, as we see here. It is also essential that there is open space under the bonnet, because as you can imagine, the bonnet can only give if there are no hard components right here, directly below it.
So the marks that we see on the vehicle here are where pedestrians would hit it.
Exactly. It's the legally defined area for testing that is based on where a pedestrian's head could hit the car, and every point within that area must be up to legal safety standards.
How about we watch a test?
Sure.
3, 2, 1, fire!
Mr. Neff, we saw just now head and leg impacts. Are impacts on other body parts tested?
We can test the impact on the hip as well, particularly with regard to the leg test that we just saw. You can picture it this way. We have a special safety precaution to protect pedestrians. It's found here, behind the bumper. This special protective foam is designed to minimize leg injuries to pedestrians.
It's important that Audi thinks about those who are more vulnerable. We have one more test to go, one I keep thinking of. It's a classic that everyone has seen footage of, the airbag test. Do you test airbags here at the Audi testing facility?
Yes, of course. The airbag must work in the greater context of the vehicle. We test that in a crash. Before installing an individual component in a car, we must do a lot of development work and perform lots of tests. We have to make sure the airbag works on its own first, and that it is reliable on a repeated basis. For example, in a car, the temperatures can range from -40 to +85 degrees Celsius. To ensure it functions reliably, we must perform a wide range of tests. If it works, we then add the parts that surround it in the car, like the instrument panel on the front passenger side. It must open the same every time, without sending parts through the air. It must function perfectly. Then we can do the system tests.
What are system tests?
A system test tests not one component but the whole restraint system, and we do that on a test sledge.
How does that work?
I'll show you that right now. This is our test sledge facility. The advantage of the test sledge is it allows us to simulate crashes without destroying an entire vehicle. We start by mounting a reinforced carriage onto the base, which is called a sledge. The crash pulse the car is submitted to is replicated with a hydraulic pulse system, so the dummy experiences the crash as if it were a real accident in an intact vehicle.
We can see the dummy behind us. What things can be tested on a test sledge?
Anything and everything, starting with the entire restraint system, airbags, safety belts, seat, steering column, instrument panel and knee bolsters. Everything that impacts the outcome of a crash. That includes child safety seats and securing loads in the vehicle.
And now, to give our viewers an idea of what sledge tests look like, we'll show you some footage of tests done here. We've already seen tests on the test sledge and we've almost reached the end. We've followed our vehicles through a range of stops. We've seen what's tested and how testing is done. Now we're here, and so is the big moment. The frontal crash awaits us. What does it cost to do a crash test on average?
If you include the cost of the car, a test like this can cost as much as 300,000 euros.
300,000 euros. So it's all carefully planned, so it works the first time.
That's right. The countdown starts as soon as we turn on the lighting. We use 140,000 watts of light power. That's a lot of light, but we need it to film with our high-speed cameras that capture images at 1,000 frames per second. Without them, we'd hardly recognize a thing in the images.
It is really bright when they're on. Would we theoretically tan if we stood under them?
Standing there for several minutes would actually give you sunburn.
Then you needn't go on holiday. How is this test controlled?
It's controlled from the crash test control room. The final countdown starts once the lights are turned on, and we run one last operational check. The instrumentation, cameras and testing system must all be in perfect working order as we are about to start.
We're really about to start. Can we be here?
We have to go. Staying here would be very dangerous.
Instrumentation ready?
Ready.
Film and camera ready?
Ready.
Hello, Bernhard. Can we start the test?
Sure, we can get started.
Attention, we're starting the test.
What has been worked toward and prepared for days is over in a few seconds. But one thing is certain, our frontal crash sure was a spectacular sight. But did it meet expectations, Mr. Neff?
At first glance, we can say we had a perfect outcome, as we expect from an Audi. The level of intrusion, the frontal deformation, and the passenger compartment form, which must remain intact in an Audi, were just how we envisioned. The final details will be brought to light in our engineers' final analysis.
Well, Mr. Neff, we are out of time. It sure went by quickly. We've seen so much, some great impressions and insights. Each and every one of us can now imagine how much time, money, energy and effort is invested here to make Audi vehicles as safe as possible. Thank you for giving me a glimpse of the events in these hallowed halls.
It was a pleasure to give you some insight into our work, Ms. König, and to be able to show our viewers what we're doing to enhance safety.
Thank you. And now it's time for Martin Neff and I to say farewell. Thanks for watching. Goodbye, and we hope you tune in next time.